Hello everybody and welcome back to the channel, and in today's episode of our Love 2D for Beginner series, we're going to make our game feel more lively by adding some simple animations. Now we're going to be discussing walk cycle animations once again. I believe we have done an episode on that in the past, but in today's episode, instead of using separate PNG images, we are going to be using what's called a single sprite sheet. And we're going to be adding simple animation, a walk cycle animation using frame by frame sprite animation in Love 2D. And here's a quick preview of what our animation will look like. So this is our character right here, and we'll be making it walk like this. A walk animation, pretty smooth, and it walks left and right. I've not added up and down animations yet, but we'll be using this sprite sheet, so you can see that it contains different images of the character walking, the walk cycle, and I have obtained that from once again itch.io. Shout out to Ordinary Bumblebee. I've taken the walk cycle from this page right here. I'll leave this link down in the description, and you can use it out and test the code on your own as well. So let's get on with the video. Now, by the end of this episode, you'll know how to load a sprite sheet onto your game, slice it into different frames, and cycle through them smoothly with delta time, and animate the character that actually moves around on your screen. So let's dive right in. First of all, like we discussed in our previous episode regarding animation, how do animations actually work? Well, frame by frame animation works like a flipbook. Each page is a still image, and flipping through them quickly creates the illusion of motion. And in Love 2D, we usually do this with something called a sprite sheet. It is an image that has multiple frames of an animation side by side, and we flip through them by slicing the image onto parts. So there are two main ways to animate in Love 2D. First, it is by using something called quads, and it is a manual method, and the next is using libraries like animate, which can simplify things. Now, learning the manual method first gives you a solid foundation, so we are going to be discussing that today. Now, let's jump right into our main.lua file. So I have here a folder called animation, and now let's be real, I just renamed the Pong folder to animation, and I have here our character.png, which is actually our sprite sheet. Now let's open our main.lua file and start with our code. So we will actually start, okay, let me just cross this and this. Now we will actually start with our function love.load. And inside love.load, we will create a variable called sprite sheet, and this will have our image. So love.graphics.new image, which will be our character.png, and after that we'll use our frame width and frame height. Now these are two variables, and in our sprite sheet, each individual frame should have a definite width and a definite height. So in our case, each frame of our walk cycle animation will have a width of 32 and a height of 50. So after that, we'll define our player table, which will define the position of our player. So first of all, okay, let me hit enter. First of all, our starting position will be 100, x equals to 100, and y equals to 100 as well. And our player's speed at which the player will walk will be 100 as well. So after that, we'll have to obtain the size of our sprite sheet in order to work with it. So first, we'll get the sheet size. So for that, we'll create two variables once again, so called local sheet width and our sheet height. Now this will be sprite sheet, which is loaded, in which our sprite sheet is loaded, and colon get dimensions. So with this, we'll have the height and width, width and height of our sprite sheet, and after that we'll create a variable called columns, which will be width divided by our sheet height. So this will give us the number of columns. And in order to slice the frames into quads, now I'll tell you in a bit of what quads actually are. We'll create a table. So first I'll write a small comment so for you guys to understand. So slice the frames into quads. We'll first create a table called quads. We'll leave it empty for now. And then we will run a for loop in which I will equal to 0, and it will run from 0 to our total number of columns minus 1. Now for each column, we will create a quad. So what is a quad? Let me write this out at first. So quads equals. So a quad is basically a window or cutout that lets you select a portion of an image. So since we want to select each individual portion of this whole sprite sheet, we'll have to use quads to select each individual portion. So instead of drawing the entire image, you can use a quad to say, I only want this portion of the image. And for that, you can use something called love.graphics.quad. And not just quad, new quad. So new quad. And this will accept our x, y. Now I'll explain all of these. Width, height, our sprite width, and our sprite height. So first of all, x is the x coordinate of the top left corner of the frame inside a sprite sheet. So suppose we want to select the first frame, right? So the x position would be the top left corner of this slice right here. So it would be right here. This position's x value would be in our x value. And similarly, if you wanted to select the second frame, the x value would be updated by its width. So we would have to put in the x value of this slice right here. And the same is with the y value. The y value is the y coordinate of the top left corner of the sprite you want to select. So if your animation has a second row as well, y would be the row's starting pixel. And as for the width and height values, these are the width and height of the individual frame. So in place of width and height, we'll keep our frame width and frame height. This is how much your each individual frame should be wide and height. So in our case, it will be this width and this height. And as for our sprite width and sprite height, you can, deduce from the name itself. It is the total width of our sprite sheet and the total height of our sprite sheet. So I hope that is clear, and we'll be using this in a way that follows. So inside our for loop, we'll be using our quads table, and we'll be basically populating our table at first. So this indicates the number. So since our quads table is empty at first, hashtag quads will equal to 0 and plus 1. So in our first index of our table, we'll fill love.graphics.new quad, and in place of x and y, we'll first write I times our frame width. So I times our frame width, and then 0 for our frame height, since our sprite sheet is only of a single line. So since our top left corner will be 0, 0, it'll equal to 0 times our frame width and 0 as well. And after that, as for our sprite width and height, we'll use our frame width and frame height. And after that, we'll use our sheet width and sheet height. Now after that, we'll end our for loop, and then after our for loop, we will create a variable called current frame, which will equal to 1 at first, since we have to start from the first frame of our quads table. So current frame will be 1. We'll also create a timer, which will initially be 0, and we'll create a frame duration. And this is basically how long a frame, each individual frame should last. So let's say 0.15. 0.15. Now this is seconds per frame. So each frame will last about 0.15 seconds, and we'll create a variable to flip our sprite from left to right. We'll create a variable called facing left, which we'll be using in the future. So false. And after that, we'll end our love.load. So inside our love.load, okay, I should put commas here. Now inside our love.load, we are loading an image called character PNG, like I've explained before, and this one has multiple frames in a row, each which are separated by 32 pixels. So 32 by 50 pixels approx. So these are separated by 32 pixels, and we grab the sheet's width, slice it into frames using graphics.new quad, and then load them into our quads table. So that is what is happening inside our love.load, and these are basically for cycling through our frame. So we have defined our current frame to be first frame at first, the timer to be 0, which we will be resetting after each frame, and our frame duration and our facing left value. So after all this, we have to cycle through our frames, and we'll be doing that using our love.update function. Now function love.update, we'll use delta time, and inside this, for our animation update, we'll be using our timer value, and to keep track of our time, we'll be increasing it by a value of delta time. So delta time is basically the time frame between two frames. So this will perfectly keep track of the time it takes or it has passed between each individual frame. And as for our animation, if our timer is greater than or equals to our frame duration, that is how much each frame should last, then we will reset the timer at first. So instead of just doing 0, we'll be subtracting the frame duration value to make it more stable, and we'll create a variable. We'll use our variable, so which is called if is moving. So if our character is moving by our keyboard input, we will change our current frame. So current frame will equal to current frame modulus the total length of our quads table plus 1. So we have basically used modulus to cycle through each and every frame present inside our quads table. So after it has reached the last frame, it will restart from 1, since our last frame's value by the total length of our quads will equal to 0 and plus 1, which will restart it from our first ever frame. So that is how we'll be using our timer to keep track and update our current frame. Now we'll define at first the default is moving to false, and we'll only set is moving to true when we detect keyboard input. So as for our movement, we'll use if love.keyboard.isDown. So let's say we'll do right. So if our player presses the right arrow, then we will first of all turn is moving to true, so that our character animates. Will set facing left to false, and then we will finally update our player x's position. I mean player's x position. So player.x plus player.speed. Oh, I meant to type out speed times dt. So this will make our player move. Now, else if our love.keyboard.isDown, the player presses our left arrow, then we'll have to do some opposites. So first of all, is moving will obviously be true since we are detecting some keyboard input, but facing left in this case will be true since the player is pressing the left arrow key. And after that, we will do player.x equals player.x minus player.speed times dt. Now if you don't know what is going on, we are basically decreasing the value of our x coordinates so that it does not only seem, it creates the effect of our player moving left, since its x coordinate value, which we measure from the left corner of our screen, it decreases, so it moves towards the left. So that is what is happening here, and it is exactly the opposite in our right arrow key. We have to increase the x coordinate so that our player's PNG moves right. So that is what is happening inside this. Now we have defined all of the logic for our player movement. Let me just close our love.update function. Now after this, we have to actually draw the player onto our screen. So in order to do that, we'll have to use our love.draw function. Now as for love.draw, we'll use if facing left. So since our default sprite shade is facing right, we'll first of all create a condition for facing left. If our player is facing left, that is, it detects the left arrow key input, we'll use love.graphics.draw. Inside it, we'll have to reference our sprite sheet, and after that, we'll have to reference our quad, which will be quads, and inside quads, we'll show our current frame on the game window. And after that, we'll use player.x, this is our x position, and player.y, this will be our y position. And after that, our rotation value will be 0. And since this image is pretty small, we want to make it visible, so I'll increase it by a factor of 2. So our x scale will be 2, and our y scale will be 2 as well. And in order to balance the flipping mechanism, I'll have to add the player's width, actually 2 times the player's width, since we are increasing by a scale of 2. So player.x, no, I mean player.width. I believe we have defined, oh, I meant frame width, sorry. Our player is essentially our sprite sheet's frame, so frame width. Now that is if our player is facing left. If our player is facing right, we'll do love.graphics.draw. Once again, sprite sheet. Oh, this should be -2 actually, since it is flipping left. This should be -2. It'll rotate our scale, so it'll be facing left. So sprite sheet. And then once again, quads, current frame. In this case, it will be player.x only and player.y only, and then 0, and then 2 and 2 for our scale. After that, we'll end the love.draw function. So let's execute our code. So before testing out our code, I found out that I referenced frame width incorrectly. I forgot to write out capital. Now let's test our code and let's see if it is working properly. So you can see that our character is walking pretty fine, and it is facing left and right as well. Pretty smooth animation, you can see. And that is how it works. So great job, you just built your first frame by frame animation, not by using separate PNGs, but this time using sprite sheets. So if you found the video helpful, hope you drop a like and subscribe to our channel for more such videos. And until our next video, bye bye and happy coding. I'll be leaving the source code for this down in the description as well. You can go check it out, and you can go check out our new episodes and latest episodes as well. So bye bye and happy coding.